All right, so let's move on to practice problem B. Practice problem B is A divided by 9 plus 1 divided by A equals 2/3. This one, again, it looks like really crazy, which is the whole purpose of why we want to practice rewriting equations, so that we can make them simpler, easier, more accessible to solve. So let's go through our list. Multiply by a common term to get rid of decimals. No, because there's no decimals involved. Factor out a negative. No, there's no negatives involved. Factor out a common term to make numbers smaller. No, not quite, because we have fractions, not big numbers. Rewrite the equation by using addition, subtraction, and inverse operation. Ooh, that seems like a viable possibility. Because again, we have this 2/3 over here on the right. So let's go ahead and, well, maybe we'll do that one second though. I don't want you to get in a bad habit of automatically moving everything to the left-hand side of the equation. And then busting fractions by multiplying by a common denominator. That's actually where we're really gonna spend some of our time today with this problem. I'm sorry, I can't decide on which color I want to use to have it show up. So here we go. We're going to bust these fractions. So we're going to first look at our denominators, 9, A, and 3. The least common denominator that they all have in common with each other would be 9 times A. We could make it 27A to include that 3, but the least common number, the smallest number that they all have in common is 9A. So what we're actually going to do is we're going to take this whole equation and we're going to multiply everything inside of it times 9A. We're going to multiply this guy, we're going to multiply that guy, and we're going to multiply that guy. We're going to use that distributive property and multiply everybody times 9A in order to simplify this problem. That's going to leave us with, let's see, for the first one, 9 divided by 9 is 1. And so that's going to leave us with just A times A, because it'll be the top A times the top A here. So that'll be A squared, because A times A is obviously A squared. The second one, the A's are actually going to cancel out with each other for that second fraction. So we're just left with 9 times 1. So we'll have plus 9 equals. And then over here for the furthest to the right, we would have, let's see, 9 divided by 3 would be 3 times 2 for that numerator that's already up there would be 6. And then times the A that's also being multiplied. So that would give us 6A over here on the right-hand side. Now this problem looks a whole lot nicer to solve for, right? So now we're going to do our next step, which is going to be that rewriting the equation by adding or subtracting. Again, because we have that power of 2 over here, we know that we need to get everything onto one side. So we're going to subtract 6A to both sides of the equation. We're going to be left with A squared minus 6A plus a positive 9 set equal to 0. And again, this would be a great final answer if it asked us to simply rewrite it into simplest form. But we actually should go one step further and factor this out. We'd factor this as being A minus 3 times A minus 3. This is a special case. Hopefully you noticed that. The first value and the third value of the trinomial are perfect squares. And the B value is, our little shortcut for how we calculate that. So we'd have A minus 3 quantity squared set equal to 0. And then, whoa. And then there was something on my screen, so I swiped it away. And so therefore, our final answer, we'd take this, we'd make it the zero product property, A minus 3 set equal to 0, and therefore A equals 3 as our final solution. Again, it kind of depends on what it's asking us. If it's asking us to simply rewrite, this is our final answer right here. If it's asking us to solve, this is our final answer right here. So again, we kind of have to pay attention to what the problem is asking for. All right, let's go ahead and move on to part C. I'm going to go ahead and erase all of this. Almost all of this. There we go. And part C, here we go. All right, C is 1.2 m minus 0.2 equals 3.8 plus m. Now the first thing you'll probably notice is that there are no powers or exponents in this problem. So that makes it a little bit nice in the sense that we probably are going to need to isolate the m's onto one side and the constants onto the other side. But let's see. So we're going to start by multiplying by a common term to get rid of the decimals in this problem. We see that there's decimals here, decimals here, decimals here. We notice that they're all to the tenths place. Because they're to the tenths place, we're going to therefore multiply by 10 to get rid of all the decimals. And again, we're going to do this to the entire equation. So here we go. Put those big braces around the whole equation, and we're going to multiply everything times 10, which really just moves the decimal over. So we have 12m minus 2 equals 38 plus 10m. Don't forget to distribute that 10 times to every single thing, including the m that's all the way over there. So here we go. Now we have these nice, pretty integers, no decimals involved, which greatly increases our chances of getting the problem right. So here we go. Let's go ahead and use the inverse operation to combine like terms on opposite sides. And then do the same for our constants. And then, of course, just our regular one-step equations, isolating that variable to get our final answer. Those ones are a little bit more straightforward. Let's go ahead and move on to part D. Let me erase all those. Let's see, got everything? Yes. Awesome. Here we go. On to part D. The D is a little bit similar to B in the sense that there's fractions involved, but this one's a little bit different because there are no variables in our denominators. So we have 3x over 4 plus x over 3 minus 1/2 set equal to 0. Again, our task is to ask ourselves, which of these rewriting steps do we want to do? Multiply by a common term to get rid of a decimal? No, there's no decimals involved. Factor out a negative? Nah, no negatives involved. Factor out a common term to make numbers smaller? Nope. Rewrite by adding or subtracting? Maybe, but we really shouldn't do that until we've busted our fractions, which would be this guy down here. So let's go ahead and bust these fractions out. We look at all the denominators and we ask, okay, we have a 4, a 3, and a 2. What's the smallest number that all three of these go into? We could just multiply them all together. 4 times 3 times 2 is going to give us 24, but I'll tell you that's not the smallest number that can actually go into, that all these go into. The smallest number is actually 12. So what we would multiply by is we would multiply this whole equation times the value of 12. Again, when we do it for the first value, it really turns into 3 times 3x because we canceled the 12 divided by 4, and that gives us 9x. For the second one, 12 divided by 3 is going to give us a times 4, so we have plus 4x. Make sure to keep track of those negatives. And lastly, we're going to cancel the 12 with the 2, and that gives us a times 6. But remember, there's that negative, so it's going to be negative 6 times 1, which is just 6. Now, we can go ahead and we can do our regular steps for solving. Combine like terms on the same side. We have 13x minus 6 set equal to 0. We're going to isolate that variable by moving the 6 to the other side. Divide by that coefficient. And keep our answer as a fraction because it would not turn into a terminating decimal. All right. And now for our last type of practice problem. You'll notice that we've done all the things except for this last one, rewriting exponents to have the same base. So here we go. Here's what that one would look like. Part E. It'd be 8 to the x power, sorry, not times x, but 8 to the x power equals 2 to the 6th power. What we're going to do here is we are going to change the base of the 8 so that it has the same base as the other side, as the 2. So the first thing we have to do is we have to ask ourselves, how do we rewrite the number 8? We would rewrite that as 2 times 2 times 2, which is the same as 2 to the 3rd power. So we start by rewriting this 8 to the x power. We rewrite the base as 2 to the 3rd power to the x power. And we practiced this way back in chapter 3 and chapter 4, if you remember. So the x power was already there, so it actually stays there as a power. And the 8 turns into 2 to the 3rd because 8 is 2 to the 3rd. Now the right side of this equation, 2 to the 6th, stays just like it's at, 2 to the 6th. Then we look at this and we're like, okay, well, I know that power to a power means multiply. So this now turns into 2 to the 3x power equal to 2 to the 6th power. Again, this guy's just moving straight on down. Now what we can do, because we have them having the same base, 2 and 2, it has nothing to do with the powers being the same, but it has everything to do with the base being the same. Once the bases are equal, if the bases are equal to each other, then we can set the powers equal to each other as well. So if the bases are equal, set the powers equal. So what that would look like is we get rid of the 2 completely, and we write it as 3x equals 6. We take this power from up here, and we set it equal to that power from the right side of the equation. We then solve for x. Final answer, x equals 2. Now you might be thinking, okay, that's super easy, awesome, great. Let's go ahead and do f. So I can show you that it is going to get a little bit more complicated than just simply 8s and 2s. All right, here we go. Part F is 4 to the 2x power set equal to 1/2 to the x plus 5 power. So this is like a massive step up from that last one. And know that there are going to be problems like in the middle there, just that this is the hardest one that you'll encounter, whereas that one was probably the easiest type of problem you would encounter as well, that previous problem. All right, so the first question is, how can I rewrite 4 and 1/2 to have the same base? Well, we know that 4 can be rewritten as 2 squared, and 1/2 actually can also be rewritten with 2 as the base, because as we learned in chapter 3, we can always flip the base. So this is actually 1 divided by 2 to the 1st power. So what we can do is to flip it back up, when we flip it across that fraction bar, we make the power, hopefully you said negative. Negative. That's how we flip it. That's why it's so important to know and have memorized all of our stuff from chapter 3 in order to be highly successful at this chapter as well. So here we go. So we've rewritten both of our bases, but we still have to move down the powers that were already there. So we're going to move down that 2x power, and we're going to move down that x plus 5 power as well. Again, we're going to need to do power to a power, which means multiply for both of them. So now we have 2 to the 4 times x power set equal to 2 to the negative 1x minus 5 power. Because we have the same base, 2 and 2, we are good to set the powers equal to each other. 4x equals negative x minus 5. We're going to move all the x's onto one side. Divide by that coefficient. And voila, there's our final solution. And all of this is rewriting exponents to have the same base so that, again, we can set the powers equal to each other. And that is all of the different ways to rewrite an equation for our Algebra 1 work.